but the behavior will remain the same, which is important. If I go back to my integration test setup, we have covered everything inside of our integration test web app factory and configured what we need for the in-memory instance of the Bookify API. And now I want to add one more class that's going to represent a test fixture that I can share between my test cases. This is going to be a public abstract class. It's going to implement the iClassFixture interface from XUnit, and I'm going to specify the integration test web app factory as the generic argument. This will allow me to inject the factory from the constructor, and then I can use the web app factory to resolve any services that I'm going to need to write my integration tests. I'm going to add 3 dependencies inside of my class fixture. First, I'm going to create a service scope for my fixture that's going to allow me to resolve any scoped services. Then I'm going to resolve an iSender instance from Mediator so that I can send commands and queries to run my integration tests. And I'm also going to resolve a database context instance that you can use to write any assertions. We're going to use our custom integration test web app factory to create a service scope, and then using the service scope I can access the service provider and resolve the iSender and the database context. And we are finally ready to start writing our integration tests. So let me pick a use case from the application layer that I'm going to write some integration tests for. And I'm going to choose the search apartments query. So this query has a start date and an end date argument, and is going to be used inside of the search apartments query handler to filter the available apartments and then return them from this query. If the start date is greater than the end date, it's going to return an empty list. Otherwise, it's going to return whatever it finds in the database. And this is another important aspect that you need to think about when you want to run your integration test using test containers or Docker in general. And this is going to be running your database migrations inside of your container instances and seeding any initial data. You can take care of this inside of the initialize async method. However, I'm going to use my Bookify API instance to run my migrations at application startup. And this will function in the same way as we were doing during development. I'm also going to uncomment the seed data extension method to populate my apartments in the database running inside of a container. So this is going to take care of automatically applying my EF core migrations and seeding the initial data that I can use for my tests. So let's go ahead and create a test folder in the integration test project, and I'm going to call it apartments. Inside of this folder, I'm going to add my test class, and I will call it search apartments tests. The test class is going to be public, and it will implement the base integration test class. Let's add the missing members, which is our constructor accepting an integration test web app factory, and then let's write our actual integration test. It's going to be asynchronous, and I'm going to call it search apartments should return empty list when date range is invalid. So I'm going to test the first case from my query handler where I specify an invalid start and end date. Let's write the arrange, act, and assert steps. In the arrange step, I'm going to create my query instance, which is going to be the search apartments query. I'm going to pick a date that is larger than the end date. So let's pick the 10th of January, and for the end date, I'm going to pick the 1st. And now you're going to see the value of writing all of the boilerplate code so far for setting up our custom integration test web app factory, because all I need to do to execute my test is say sender and send my query instance, and I'm going to get back a result containing a read-only list of apartment responses. And now I can write my assertion. For example, I can assert that is success should be true, and I'm also going to assert that the value, which is our apartments collection, should be empty because we specified an invalid date range. Let's go ahead and run our first integration test, and while the test is running in the background, I'm going to show you the Docker desktop view where you can see the throwaway container instances being created by the test containers library. Keycloak is going to import our Bookify realm using the realm import file, and after we have completed our test, test containers is going to do the cleanup and dispose of all of the container instances, which you can see just happened. And if we take a look at our test case, you can see that it has succeeded. I'm going to add one more test case here, and this time I'm going to provide the correct values for the start and the end date, and I'm expecting that the collection of apartments should not be empty. Let's run our integration tests again, and you can see that both of our tests are passing, which means that the seeding of the initial data to the database inside of our container is working as expected. And another thing I wanted to highlight is how long it takes to complete a particular integration test. For example, this test took 1 second to complete, whereas our unit tests can complete in just a few milliseconds. A few more remarks about the current implementation. Because we are using the base integration test as our class fixture, this means that any container instances inside of this class fixture are going to be shared for all of your test cases inside of a single test class. In other words, the Postgres container, Redis container, and the Keycloak container are going to be shared inside of all of the test cases in the search apartments test class. If I create another test class with more integration tests, they are going to run using different container instances. And you should be aware of this when it comes to resource consumption on your machine, because spinning up and getting rid of so many containers can definitely take a toll on your system. Let me add a few more integration tests. I'm going to create a new folder and I will call it bookings. Inside of this folder, I'm going to add a new test class. I will call it get bookings tests, and this is going to be the implementation of our test class. I'm going to have a static booking ID that I'm going to use to create a get booking query instance, and I'm going to send this using Mediator and verify that I get the correct error object back. Let me also create an integration test for the confirm booking use case. This is going to be a command, and let me add the implementation. So it's going to be very similar. Creating the command instance, passing it the booking ID, sending this using Mediator, and then verifying the error that we get back. So I'm first going to run all of the integration tests, and you will see that all of the integration tests will pass because there is no booking present in the database, so the command and the query both fail. If you want to be able to test this correctly, you will need to do some test setup, either by using the database context that I define in the base integration test class and populating the database directly, or you can create a command instance and send it to run some use cases that are going to fill in the booking table. I also want to show you how this type of integration test is very valuable because of the way it's being executed in memory. Notice that I'm using the iSender from Mediator here to send my command, and in my other test class to send my query. So if I go over to the bookings controller, which is where I am sending the get bookings query, you can see that this is the same setup like inside of our integration test. So this kind of integration testing runs one level below your .NET controllers. However, I am still executing my entire Mediator pipeline, and this is what I want to show you. I'll go into my application project and let's go to our behaviors. Let's add a breakpoint in the validation behavior and inside of the logging behavior, and I'm going to take my confirm booking test case and let's debug this integration test. This is going to take some time because test containers is spinning up the container instances in the background, but eventually we are going to hit the breakpoints that I set inside of our Mediator behaviors. And you can see that we do hit the breakpoint in the logging behavior, which is the first one in the pipeline, and the request object here is the confirm booking command that we sent in the integration test. I don't need to go through the entire pipeline, but here I'm going to press continue, and you will see that we hit the breakpoint inside of the validation behavior. If there are any validators present for your class, they are going to execute. And in this case, because I don't have any validators, I'm going to proceed to my command handler. I'm going to press continue, and you can see that I hit the breakpoint in the confirm booking command handler object. So let's step through the handle method. We're going to run the method on the booking repository, and this is an actual instance of the booking repository class. It's using the database context under the hood, which can connect to the Postgres instance running in a Docker container. And we are doing proper integration testing with real external dependencies. None of this is using any mocks or fake providers like the EF Core in-memory provider. Our integration test is using the real deal and connecting to a real Postgres database under the hood. And this is how you can write quality integration tests for your clean architecture implementation.